Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, part 9 on the chapter of rational numbers, I will solve selected problems from the exercise 1D and 1E from the textbook of author RS Aggarwal, which is based on the multiplication, division of rational numbers and their properties and the concept of multiplicative inverse and multiplicative identity. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, I will strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. I also suggest that if you have not watched the previous videos from part 1 to part 8, you please watch them to maintain the continuity of your study on the chapter of rational numbers. So let's get started with this video. Okay, so I have the problems from exercise 1D and 1E. 1D is based on the multiplication of rational numbers and exercise 1E is based on the division of rational numbers. I will do selected problems that will cover the most variants of the problems. Okay, so let's now exercise 1D, which is based on multiplication of rational numbers. I think it is not necessary to do the problem number 1. You have to find the multiplication product of two rational numbers. It is pretty simple. Anyway, just for the sake of completeness, let's do few problems. Let's say part 1, problem number part 10. It says that minus 7 by 6 multiplied by 24, and we know that the product of two rational numbers, the formula is, if you have two rational numbers p by q and r by s, the product is the result is the product of the numerators divided by the product of the denominators. So we will have minus 7 multiplied by 24 divided by 6 into 1 by 1, because 24 we can represent as a rational number as 24 by 1. So this is, now if you divide 624 with 4, this is minus 28. Let's do another one. Let's say 8. It is minus 13 by 15 multiplied by minus 25 by 26. So this is nothing but minus 13 multiplied by minus 25 divided by 15 multiplied by 26. Now in the numerator, minus 13 and minus 25, the minus will cancel out, and if you divide, will cancel out. So we can write this as 13 into 25 divided by 15 by 26. 13 will divide 26 with 2, and 5 we can divide 15 with 3, and 25 by 5. So this is 5 by 6. Let's do part 6, which is 25 by minus 9, 25 by minus 9 multiplied by 3 by minus 10. Now for finding the product of two rational numbers, you can directly apply the formula, that is instead of first converting each rational number to standard form, or at least to make the denominator positive, it is not necessary. You can directly apply the formula 25 multiplied by 3 divided by minus 9 multiplied by minus 10. You apply the formula, and then whatever the result is, if that result is not in standard form, then you can convert that rational number into standard form. So minus 9 and minus 10 in the denominator, the minus will cancel out. So we will have, we can cancel, sorry, you cannot do this like this. Anyway, so okay, so this is 25 multiplied by 3 divided by 9 by 10, as minus cancels out. Now you divide 3 9 with 3 as 3, 5, 5, 5, 2. This is also 5 by 6. So you know, you got the idea how to find the product of two rational numbers. Okay. What is question number 2? Verify each of the following. The question number 2, it is asking to verify whether the left hand side is equal to right hand side. Now you can verify all these problems, the problem 2, by using the commutative law. As you can see that all the equality, both the left hand side and the right hand side are the product of two rational numbers. So let's say if we do part 4, it is minus 8 multiplied by minus 13 by 12 is equal to minus 13 by 12 multiplied by minus 8. So this we have to verify. Now you can solve like this. LHS is minus 8 multiplied by minus 13 by 12. Using commutative law, you know that for any numbers in general, for any kind of number system, whether it's rational numbers, fractions, natural numbers, whole numbers, integers, we all know that A into B, where A and B are numbers, in this case it will be rational numbers, is always equal to B into A. That is, the multiplication is always commutative. So using commutative law, we can say that minus 8 multiplied by minus 13 by 12 is equal to minus 13 by 12 into minus 8, which is equal to RHS. And you should write that using commutative law or commutative property. So this way you can solve all the parts of the problem 2. So I did not solve the other problems. Okay, let's move on to question number 3, where also it is asked to verify whether the left hand side is equal to the right hand side or not. Let's do part 1. It is asked to find whether 5 by 7 multiplied by 12 by 13 multiplied by 7 by 18 is equal to 5 by 7 multiplied by 12 by 13 into 7 by 18. Now LHS is equal to 5 by 7 multiplied by 12 by 13 multiplied by 7 by 18. Now using associative law of multiplication, we know that multiplication of rational numbers obeys the associative law. I can change the grouping. So I can say that this is equal to 5 by 7 and change the grouping from the first and second rational numbers to I will group the second and the third rational numbers. So 12 by 13 into 7 by 8. So in the bracket you have to write that using associative property or law which is equal to, you can see this is equal to the right hand side. Using the same concept of associative property of multiplication, you can verify all the other problems, all the other parts of the question number 3. Now fill in the blanks. Fill in the blanks are also based on using the commutative law and associative law of multiplication. So let's do let's do part 3. Okay, so 15 by 7 multiplied by minus 21 by 10 multiplied by minus 5 by 6 is equal to, we have to fill in the blanks over here. This is equal to given minus 21 by 10 multiplied by minus 5 by 6. Now let's say in the fill in the blanks, the rational number, whatever the rational number it will be, let's say we assume it to be x. Okay, now The left hand side is equal to, we can write it, the left hand side, given left hand side is 15 by 7 multiplied by minus 21 by 10, and it is multiplied by minus 5 by 6. This we can write it as 15 by 7 multiplied by, we can change the grouping. Since multiplication is of rational numbers follows the associative law, we can change the grouping. In the given left hand side, the grouping is between 1 and second rational number, and we can change that to second and third rational number. That is, we can group second and third rational number, and the value remains the same. So we can write it like this. Okay. Now, we can say that this is equal to the right hand side, which is equal to x, as in the fill in the blanks, we assume that rational number to be x. This is equal to minus 21 by 10 multiplied by minus 5 by 6. Now from this we can cancel out minus 21 by 10 multiplied by minus 5 by 6, because it is happening on both sides. So this is a general concept that if you have an equality of the form a multiplied by c is equal to b multiplied by c, where a, b, c are some numbers, they could be integers, rational numbers, fractions, decimals, natural numbers, whole numbers, whatever, and c is some non-zero constant, non-zero number, you can always cancel out c and say that a equals b. So from here, this equality, we can cancel out this part, same. So this will imply 15 by 7 is equal to x. So x is equal to 15 by 7. So let's do another problem. Let's say we are doing let's say part 2 of problem number 4. So we have to verify minus 38 multiplied by minus 7 by 19 is equal to minus 7 by 19 multiplied by fill in the blanks. Now this is super easy. We know that if you consider this, the proper way of solving this problem is that you consider this as x in the fill in the blanks. Now LHS is equal to minus 38 multiplied by minus 7 by 19. This you can write as minus 7 by 19 multiplied by minus 38 using the commutative law, commutative property of multiplication, commutative property. Okay, so this is equal to RHS is equal to minus 7 by 19 multiplied by x. Now we can cancel out minus 7 by 19 from both sides. So this implies minus 38 is equal to x. So x is equal to minus 38. Okay, let's move on to question number 5. Question number 5. What questions do we have? Okay. Question number 5, it is asking to find the multiplicative inverse or reciprocal of. Okay, so let's do few of them. I have not solved all of them. So it is asking what is multiplicative inverse. I am in short writing MI for multiplicative inverse of 13 by 25 is equal to, we know the notation wise, the multiplicative inverse of 13 by 25 or the reciprocal of 13 by 25 is represented as 13 by 25 to the power minus 1, and we know that this is actually its value as a rational number will be, we just interchange the numerator and the denominator. So this becomes 25 by 13. What is the MI multiplicative inverse of 0 by 2? Uh, as per the formula, this is as per the notation, this will be 0 by 2 to the power minus 1, and this should be 2 by 0, which is undefined. Therefore, uh, therefore, this mi, multiplicative inverse of 0 by 2, does not exist. Does not exist because multiplicative inverse only exists for positive rational numbers, and 0 by 2 is a multiplicative inverse only exists for non-zero rational number, and 0 by 2 is equal to 0. Okay, let's do 3. These are pretty simple. I hope it will be super easy for you to find the multiplicative inverse of any rational number. So mi of minus 7 by 24 is equal to, notation wise, it is minus 7 by 24 to the power minus 1, and the actual value is, you just interchange the numerator and the denominator, but you see the denominator now becomes negative, so make it positive, make the denominator positive, and it becomes minus 24 by 7. Okay, let's move on to question number 6. So these are all based on the multiplication of rational numbers. Now it is asking to find the value of minus 7 to the power minus 1. Now anything to the power minus 1 means the reciprocal of the number or multiplicative inverse. Now this is actually minus 7 in the form of rational number will be minus 7 by 1 minus 1. Now this will be, you would interchange the numerator and the denominator, it becomes 1 by minus 7. Now this is not in standard form, you convert it to standard form so that the denominator is positive and it becomes minus 1 by 7. Okay, this was part 3. What else do we have? Let's see part 4. What is 1 by minus 3 reciprocal or multiplicative inverse of 1 by minus 3? So this is nothing but you just interchange the numerator and the denominator. This becomes minus 3 by 1, which is equal to minus 3. Let's see 2. We have to find minus 4 by 9 to the power minus 1, that is the reciprocal of minus 4 by 9, which is equal to 9 by minus 4. This is equal to minus 9 by 4. Okay, let's move on to question number 7. Okay, these are the verify the following. We have to verify the left hand side is equal to the right hand side. Okay, so I am skipping some steps. I hope you will understand. I am directly writing that LHS, given LHS, this is part 1. LHS is equal to 3 by 7 multiplied by 5 by 6 plus 12 by 13. This is the left hand side, and applying the distributive law of multiplication over addition of rational numbers, we can say that this is equal to 3 by 7 multiplied by 5 by 6 plus 3 by 7 multiplied by 12 by 13, which is exactly the given right hand side. So it is proved. Okay, let's do number 3. The LHS, I will start with the LHS and prove that it is equal to the RHS. Now LHS is minus 8 by 13 by 3 plus minus 13 by 12 multiplied by 5 by 6. Now this is equal to, if I distribute the multiplication over the addition, I will have minus 8 by 3 multiplied by 5 by 6 plus the minus 13 by 12 multiplied by 5 by 6. This is equal to the given RHS. Now, what is the associative law that we are using? In the first case, the associative law that I used, the first part, problem number 1 of problem 7, it was that if you consider ABC as 3 rational numbers, if you consider, or let's say XYZ, let's consider XYZ are rational numbers. So I applied the formula of associative law, of distributive law, of multiplication over addition like this. If we have x multiplied by y plus z, we know this is equal to x multiplied by y plus x multiplied by z. And for part 2, the formula, both are a distributive law of multiplication over addition, but in a little different arrangement or order. So similarly, if we have y, if we have something like this, x plus y multiplied by z, this will be equal to, using the same distributive law of multiplication over addition, this will be x into z plus y into z. Okay. I hope you can do the remaining problems. The concept is same. You have to apply the distributive law of multiplication over addition and subtraction. Okay. So let's move on to problem number 8. Name the property of multiplication illustrated by each of the following statements. Okay. So we have to identify which property of multiplication has been applied in the equality. Now, first one, it is given that minus 15 by 8 multiplied by minus 12 by 7 is equal to minus 12 by 7 multiplied by minus 15 by 8. You can clearly see this is commutative property. This is commutative property. That is, if x and y are rational numbers, then x into y is equal to y into x. So commutative property has been applied. If you see part 2, it is given that minus 2 by 3 multiplied by 7 by 9 multiplied by minus 9 by 5 is equal to minus 2 by 3 multiplied by 7 by 9 multiplied by 9 by 5. This is associative property. This is associative law or associative property has been used. Associative property of multiplication, that is x into y, the whole into z is equal to x into y into z. That is, we can change the grouping. Okay. Let's see 3. It is given minus 3 by 4 multiplied by minus 5 by 6 plus 7 by 8 is equal to minus 3 by 4 plus minus 5 by 6. Sorry, this will be multiplication, multiplied, and then plus minus 3 by 4 multiplied by 7 by 8. Now, this is clearly, you can see, this is distribution, distributive law, over addition. And the formula is that x into where x, y, z are rational numbers, x into y plus z is equal to x into y plus x into z. Okay, now the remaining you can do, they are very simple, but let me do a few of them. Let's say 4, it is given that minus 16 by 1 minus 16 by 9 divided by 1 is equal to 1 multiplied by minus 16 by 9 is equal to minus 16 by 9. This is basically property of 1 with respect to multiplication of rational numbers. That is, if you multiply 1 with any rational number, the result is the rational number itself. This is known as property of 1. And part 5, you can see it's a commutative law. No, it is not commutative law. Part 5 is minus 11 by 15 multiplied by 15 by minus 11 is equal to 15 by minus 11 multiplied by minus 11 by 15 equals to 1. This is multiplicative inverse. Concept of multiplicative inverse, or the product of a rational number and its multiplicative inverse is 1. The concept is multiplicative based on multiplicative inverse, and that p by q, if p by q is a rational number, then p by q multiplied by its multiplicative inverse or reciprocal is equal to 1, where of course the rational number p by q should not be equal to 0. And the last one, 6, this is minus 7 by 5 multiplied by 0 is equal to 0. This is property of 0. That is, if you multiply 0 with any rational number, the result is always 0. Okay. So while I am solving the problem, you can pause the video and take a screenshot for your future reference. Let's do problem number 9. Part 1. The product of a rational number and its reciprocal is always equal to 1. So we know that p by q multiplied by the reciprocal of p by q, that is p by q to the power minus 1, is always equals to 1. Part 2, 0 has reciprocal. I think it will be no. 0 has no reciprocal because the reciprocal only exists for non-zero rational numbers. So reciprocal of 0 or does not exist, or multiplicative inverse of 0 does not exist. So it should be 0 has no reciprocal. Part 3, the numbers dash and dash are their own reciprocals. Of course, the numbers are, we have already discussed, these are the only two numbers, 1 and minus 1, which are equal to their reciprocals. So 1 is equal to the reciprocal of 1. Similarly, minus 1 is equal to the reciprocal of minus 1. Or in other words, the reciprocal of 1 is 1 and reciprocal of minus 1 is minus 1. Part 4, the 0 is dash the reciprocal of any number. 0 is 0 is not, I think it will be not. 0 is not the reciprocal of any number, which means that there does not exist any number whose reciprocal is 0, because if there exists a number if there exists a number whose reciprocal is 0, then the reciprocal of 0 should be that number, and we know that the reciprocal of 0 does not exist. So there should not be any rational number whose reciprocal will be 0. Part 5, the reciprocal of a where a not equals to 0 is 1 by a, which is denoted as, the notation is a to the power minus 1. This is the notation, a to the power minus 1, but the actual value in terms of the rational number in the form of rational number is 1 by a. Part 6, the reciprocal of 1 by a where a not equals to 0 is a. Why? Because we know that 1 by a its reciprocal is nothing but we just interchange the numerator and the denominator, that is a by 1, which is equal to a. 7. The reciprocal of a positive rational number is, the reciprocal of a positive rational number is a positive rational number. Rn means rational number. Part 8, the reciprocal of a negative rational number is negative rational number. Now I am writing for part 7 and part 8, I am writing the part 7, I am writing positive rational numbers. It could also be in the fill in the blanks, it could also be that the reciprocal of a positive rational number is greater than 0, and the reciprocal of a negative rational number is less than 0. A rational number less than 0 and a negative rational number is same. Similarly, a rational number, positive rational number is same as a rational number greater than 0. So this brings to an end in solving the problem of exercise 1D, which is based on multiplication of rational numbers. Now let's solve the problems of 1E, which is based on the division of rational numbers. Okay. So it is, the first problem is about simplification. So let's see 1. We have 4 by 9 divided by minus 5 by 12, and we know that when we divide a rational number by another rational number, the result is actually we multiply the first rational number with the multiplicative inverse of the second rational number. So this will be 4 by 9 multiplied by, I am using mi to denote multiplicative inverse. So multiplicative inverse of minus 5 by 12. So this is equal to 4 by 9 multiplied by, what is multiplicative inverse of minus 5 by 12? You just reverse the numerator and the denominator. So this will be 12 by minus 5. And now you have the product of two rational numbers. You apply the basic formula. The numerators, it will be the product of the numerators divided by the product of the denominators. So this becomes, if you cancel, do some cancellation, 3, 4, this is 14, 16 by minus 15. The denominator is negative, you have to make it positive, and it becomes minus 16 by 15. Okay, let's do part 4. It is minus 1 by 10 divided by minus 8 by 5. This is equal to minus 1 by 10 multiplied by multiplicative inverse of minus 8 by 5. This is equal to minus 1 by 10 multiplied by multiplicative inverse or reciprocal of minus 8 by 5 is 5 by minus 8. Now you apply the standard formula of multiplication of two rational numbers. It becomes minus 1 multiplied by 5 divided by 10 into minus 8. That is, we multiply the numerators and we multiply the denominators and take the division. So this is minus, now if you do some cancellation, 5 cancels 10 with 2. So this is minus 1 by minus 16. Minus minus cancels out, it is 1 by 16. Okay. Now let's do the last one, part 6. if I okay, so it is part 6 is minus 65 by 14 divided by 13 by 7. 13 by 7. So this is equal to minus 65 by 14 multiplied by multiplicative inverse of 13 by 7. This is equal to minus 65 by 14 multiplied by multiplicative inverse of 13 by 7 is 7 by 13. Now if you do cancellation, 7 divides 14 with 2, 13 divides 65 with minus 65 with minus 5. So this is equal to minus 5 by 2. Okay. Let's move on to question number 2. Question number 2, verify whether the given statement is true or false. Now, okay, so problem number 2, let's see part 1. How do we do this kind of verification? It is asking to verify whether 13 by 5 divided by 26 by 10 is equal to 26 by 10 divided by 13 by 5. Now we have studied that division is not, the operation of division is not commutative, but it is not that in it will never be commutative. In some cases it might be commutative, but the general concept is that, idea is that a division of rational numbers is not necessarily commutative. That is, it is not the case that you can always the division is commutative. In some cases it may be, in some cases it may not be. For example, in this case I do not think they are commutative, because the left hand side, so if the left hand side is 13 by 5 multiplied by the multiplicative inverse of 26 by 10, that is 10 by 26. If you do cancellation, it will be equals to 1. RHS, whereas RHS is equal to 26 by 10 multiplied by 5 by 13. The multiplicative inverse of 13 by 5 is 5 by 13. So this is equal to, if you do cancellation, this is also equal to 1. This is also equal to 1. Now why is this so? Why is this so? I think I did it right. 13 by 5 multiplied by 10 by 26. 10 by 26. And this is okay. And 26 by, the right hand side is 26 by 10 multiplied by 5 by 13. Okay. So this is coming to be equal. This is the left hand side is equal to right hand side, even though in general the division operation of rational numbers is not commutative. Is not commutative. Now, so in this case it worked. So let's say when do we have, if we have two rational numbers, division of rational numbers, so division of P by Q and R by S, if it is equal to R by S divided by P by Q, then what we are getting, this implies the left hand side will be PS by QR, and the right hand side will be RQ by SP. Okay. Anyway, so just In general, we know that division operation is not commutative, but for solving this kind of problem, it is better that you evaluate both the sides, left hand side and the right hand side, and then you match the values. In this case, they are equal. Okay, so let's see part 2. It is asking to verify whether minus 9 divided by 3 by 4 is equal to 3 by 4 divided by minus 9. So the LHS is equal to minus 9 multiplied by 4 by 3, because we know that division operation, the using the formula of division of two rational numbers, it will be minus 9 multiplied by the multiplicative inverse of 3 by 4, which is 4 by 3. This is equal to, if you do cancellation, minus 3, this is equal to minus 12. And the RHS is equal to 3 by 4 multiplied by 1 by minus 9. This is equal to 1, if you do cancellation, minus 3, this is equal to 1 by minus 12, this is equal to minus 1 by 12, and so this is not equal to LHS. So it is not verified. For 2 it is not verified, it is not the same. LHS is not equal to RHS. Okay, I will do the part 4. It says to verify minus 7 by 24 divided by 3 by minus 16 is equal to 3 by minus 16 divided by minus 7 by 24. Now let's see what is LHS. LHS is equal to minus 7 by 24 multiplied by the multiplicative inverse of 3 by minus 16, which is minus 16 by 3. If you do some cancellation, this will be the minus minus cancels out, so we can write this as 7 into 16 divided by 24 into 3. If you divide, cancel with 4, this is 4 and this is 6, so this is 7 by 18. 7 by 18. No, this will be, sorry, let's not cancel with 4, let's say cancel with 8, we get 2 and 3. So this is 14 by 9. And the RHS is equal to 3 by minus 16 multiplied by multiplicative inverse of minus 7 by 24, 24 by minus 7. This is equal to 3 multiplied by 24, and the minus 16 and minus 7, minus minus cancels out, so we can write 16 into 7. Now what is this? Divide by 8, 3, 2, this is 9 by 14, not equal to LHS. So this way you have to evaluate both the sides, LHS and RHS, and then compare the the values of the LHS and RHS. Okay. Now let's do the problem number 4. These are what problems? The product of two rational numbers is minus 9. If one of the numbers is minus 12, find the other. So if we consider the one number, find the other. If the other, let other rational number be x. This implies what is given, from what is given, the product of two rational numbers is minus 9. If one of the numbers is minus 12, so it is given that minus 12 into x is equal to minus 9. So this implies x equals to minus 9 divided by minus 12. So you know that if you have this kind of equation where a and b some numbers, definitely A and B, A is non-zero. You know that this implies, and X is unknown, X is equal to B divided by A. So this is equal to minus 9 by 1 divided by minus 12 by 1 if you convert it into, if you write it in the form of rational numbers. So this is equal to minus 9 by 1 multiplied by multiplicative inverse of minus 12 by 1, that is 1 by minus 12. So this is equal to minus 9 by minus 12. Minus minus cancels out from both numerator and the denominator. This is 9 by 12. Now this is not in standard form. Convert it into standard form by dividing both the numerator and the denominator with the HCF. It becomes, HCF is 3. So 3 and 4. So the answer is 3 by 4. So the other number is, X is, the other rational number is 3 by 4. Okay. Let's solve now problem number 5. The product of two rational numbers is minus 16 by 9. If one of the numbers is minus 4 by 3, find the other. So we have, if we assume the other rational number is X, it is given that minus 4 by 3 multiplied by X is equal to minus 16 by 9. So this implies X is equal to minus 16 by 9 divided by minus 4 by 3. This is equal to minus 16 by 9 multiplied by the multiplicative inverse of 3 by minus 4 by 3, that is 3 by minus 4. This is equal to minus 16 into 3 divided by 9 into minus 4. So minus minus cancels out from both the numerator and the denominator, and we get 16 to 3 divided by 9 into 4. And now if you do cancellation, we get equals to 4 by 3. So the other rational number is 4 by 3. Okay. Let's do problem number 6. By what rational number should we multiply minus 15 by 56 to get minus 5 by 7? So let the rational number be X. So what is saying, what we can say from the given problem statement, that if you multiply minus 15 by 56 with the other rational number, with the rational number, we have assumed the rational number to be X, we get minus 5 by 7. So this is the mathematical statement. Now we have to find X. So this implies X is equal to minus 5 by 7 divided by minus 15 by 56. This is equal to minus 5 by 7 multiplied by the multiplicative inverse of minus 15 by 56 is 56 by minus 15. This is equal to minus 5 multiplied by 56 divided by 7 into minus 15. Now minus minus cancels out. We can write it as 5 multiplied by 56 divided by 7 multiplied by 15. Now if you do cancellation, we get, this is as equal to 8 by 3. So the number that should be multiplied with minus 15 by 56 to get minus 5 by 7 is 8 by 3. Okay. Let's do problem number 7. By what rational number should minus 8 by 39 be multiplied to obtain 1 by 26? So it is the mathematical statement will be, if we assume that the rational number that need to be multiplied is X, we get minus 8 by 39 multiplied by X is equal to 1 by 26. So this implies X is equal to 1 by 26 divided by minus 8 by 39. This is equal to 1 by 26 multiplied by 39 by minus 8. This is equal to 1 into 39 multiplied by 26 into minus 8. Now if you do cancellation, if I divide cancel with 39, 13, this is 3, this is 2. So this is 3 upon minus 16. Now you have to make the denominator positive, so this becomes minus 3 by 16. So the number that need to be multiplied with minus 8 by 39 to get 1 by 26 is minus 3 by 16. Okay, let's do problem number 8. By what number should minus 33 by 8 be divided to get minus 11 by 12? So let that rational number be x. So the mathematical statement is minus 33 by 8 divided by x is equal to minus 11 by 2. Now this implies minus 33 by 8 divided by x means multiplied by the reciprocal of x, that is 1 by x, equals to minus 11 by 12. So this means that 1 by x will be equal to minus 11 by 12 divided by minus 33 by 8. This is equal to minus 11 by 12 multiplied by 8 by minus 33. This is equal to minus 11 multiplied by 8 divided by 12 into minus 33. Now if you do cancellation, this will become 4, 2, 4, 3, this 3. This is 2 by 9. Now, so now we have 1 by x is equal to 2 by 9. We know, and we need x. We need x. Now what is x? 1 by, from, we know that multiplicative inverse x is equal to the multiplicative inverse of 1 by x. We can write this because the multiplicative inverse of 1 by x is x. So this 1 by x we know, it is 2 by 9. So it will be the reciprocal of 2 by 9, that is 9 by 2. Okay, let's do problem number 9. But divide the sum of 13 by 5 and minus 12 by 7 by the product of minus 13 by 7 and minus 1 by 2, 1 by minus 2. So it is asking divide the sum of, okay, so we have to divide the sum of 13 by 5 and minus 12 by 7. This is the sum. We have to divide this by the product of minus 31 by 7 and 1 by minus 2. Okay, so now how do we do this? Now first of all we have to it is better that we have to apply, if we apply the Bodmer's rule, we always evaluate the brackets. So let's evaluate the brackets first, and the first bracket which is a sum of two rational numbers, let's do that first. It will become 13. The LCM of 5 and 7 is 35. So this becomes 13 into 7 plus minus 12 into 5 divided by 35 divided by, and let's evaluate the second bracket. This becomes minus minus cancels out, minus 31 and minus 2 minus cancels out, and this becomes 31 by 14. Okay. Now if we further simplify the first bracket, this is 91 minus 60 divided by 35 divided by 31 by 14. Now this is, if we further simplify the value inside the first bracket, this is 31 by 35 divided by 31 by 14. So this is equal to 31 by 35 multiplied by 14 by 31. 31 cancels out. We divide 14 and 35 with 7. This is 2. This is 5. So the answer is 2 by 5. Okay. So whenever you have this kind of expression to simplify, always evaluate the value inside the brackets, and then use the rule that you must first apply, evaluate multiplication, division, multiplication before addition and subtraction. Let's do problem number 10. Divide the sum of 65 by 12 and 8 by 3 by their difference. Okay, divide the sum. Okay, so sum is equal to 65 by 12 plus 8 by 3, and difference is equal to 65 by 12 minus 8 by 3. So we have to divide the sum by the difference. Now so we have to evaluate the sum divided by the difference. This is equal to, we have to evaluate 65 by 12 plus 8 by 3 divided by 65 by 12 minus 8 by 3. So first we have to evaluate the brackets. So the sum becomes 65 plus 32 divided by 12, and the difference becomes 65 minus 32 by 12. This is equal to 97 by 12 divided by 3 and 3, 33 by 12. Okay, so this is equal to 97 by 12 multiplied by 12 by 33. 12 cancels out, and 97 by 33. So this is equal to 97 by 33. Okay, fill in the blanks. Problem number 11 is fill in the blanks, part 1. So in the fill in the blanks, the way I will do it, in the fill in the blanks, I will assume that the rational number that need to be filled with is x. So the problem statement becomes 9 by x divided by x is equal to minus 3 by 2. So this implies 9 by x multiplied by 1 by x is equal to minus 3 by 2. This implies 1 by x is equal to minus 3 by 2 divided by 9 by 8. This is equal to minus 3 by 2 multiplied by 8 by 9. If you do cancellation, you will see the result is minus 4 by 3. Now 1 by x is equal to minus 4 by 3. Now we have to find x. So x is equal to 1 by reciprocal of 1 by x. This is equal to minus 4 by 3 reciprocal of minus 4 by 3. This is equal to 3 by minus 4. This is equal to minus 3 by 4. So the fill in the blanks, the answer will be minus 3 by 4. Part 2, x divided by minus 7 by 5 is equal to 10 by 19. 10 by 19. So this implies, now you can see that the way you can solve it is that x divided by minus 7 by 5 is equal to 10 by 19. Now x divided by minus 7 by 5 I can say as x multiplied by 5 by minus 7 is equal to 10 by 19. This implies x, we can always say that this implies x is equal to 10 by 19 divided by 5 by minus 7. This is equal to 10 by 19 multiplied by minus 7 by 5. If you do cancellation, see this is minus 14 by 19. So x is equal to minus 14 by 19. Part 3, x divided by minus 3 is equal to minus 4 by 15. Now this implies x divided by minus 3 means x multiplied by 1 by minus 3 is equal to minus 4 by 15. This implies x is equal to minus 4 by 15 divided by 1 by minus 3. This is equal to minus 4 by 15 multiplied by minus 3 by 1. Now if you do cancellation, 3 divides minus 3 with minus 1 and this is 5. So this is 4 by 5. X is 4 by 5. Okay. Part 4, it is minus 12 divided by the fill in the blanks I am assuming to be x is equal to minus 6 by 5. This implies minus 12 multiplied by 1 by x is equal to minus 6 by 5. This implies 1 by x is equal to minus 6 by 5 divided by minus 12. This is equal to minus 6 by 5 multiplied by 1 by minus 12. So this is equal to minus 6 divided by 5 into minus 12. So this cancels with 2. This is equal to 1 by 10. So 1 by x is equal to 1 by 10. This implies x is equal to the reciprocal of 1 by x, that is the reciprocal of 1 by 10. This is equal to 10. Okay, let's do problem number 12. These are, I guess, true or false statement. So first one, are rational numbers always closed under division? No. Are rational numbers always closed under division? It is yes. You can say yes because if you consider the rational numbers, if when you are doing a division of two rational numbers, if p by q is a rational number, if you are dividing this rational number p by q by r by s, and if you consider that r by s is a non-zero rational number, then of course p by q divided by r by s is always a rational number. But also you cannot do division with a zero rational number. If r is by s is equal to 0, then you cannot do the division. So for some rational numbers the division is not defined. So I'm not really sure what to say. If you are talking about a valid division, that is a division by a non-zero rational number, then of course if you divide any rational number by another non-zero rational number, then of course it is closed. So I am assuming it's yes. Part 2, are rational numbers always commutative under division? Are rational numbers always commutative under division? Commutative under division? No. No. For example, let's say 2 divided by 3 is definitely not equal to 3 divided by 2. Since this is 2 by 3 and this is 3 by 2, and so 2 by 3 is not equal to 3 by 2. So definitely rational numbers are not always commutative under division. Are rational numbers always associative under division? No. It is not associative under division, because if you consider, let's say, I am taking a very simple example to prove that rational numbers are not always associative under division. Let's say we have to find 1 divided by 2 divided by 3. Now, if you do the association like this, this is equal to 1 by 2 divided by 3. This is equal to 1 by 2 multiplied by 1 by 3. This is equal to 1 by 6. But if you do 2 divided by 3, if you do this kind of association, this is equal to 1 divided by 2 multiplied by 1 by 3. This is equal to 1 divided by 2 by 3. This is equal to 1 multiplied by 3 by 2. This is equal to 3 by 2, and this is not equal to 1 by 6. So we can clearly see that we have found an example where the division is not associative on rational numbers. So definitely rational numbers are not always associative under division. Now part 4. Can we divide 1 by 0? Can we divide 1 by 0? No. No. Division by 0 is undefined in arithmetic. So definitely no. Okay. So this brings to an end in solving some major selected problems from exercise 1D and 1E, which are based on the addition and multiplication and division of rational numbers and their properties, and the multiplicative inverse and multiplicative identity. So I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So we have practically completed the first chapter, that is rational numbers. We have sorry, I am not yet complete. In the next video, I will discuss about how do we find some rational numbers between two given rational numbers using some specific property that I will discuss in the next video. And once that video is complete, I have to complete the exercise 1F and then do the objective questions, MCQ, and then the test paper 1. After all these are complete, I will then prepare to practice sample test papers 1 and 2 based on rational numbers. So that will bring an end to the chapter rational numbers. So please stay tuned for the next video about how to find rational numbers between two given rational numbers, and also I will solve the problems of the exercise 1F. So thanks for watching, and until the next video, take care and bye.